Ryan, hello, good morning. It was fun doing the stream yesterday, and I got some comments, and I thought I would just continue exploring this thing, just for reflection and for fun. Woke up this morning, I did a boo boo in production at my current employer. Like, I've been working on this very impactful core functionality of authorization and caching, and putting those two like they're complicated or complex in their own rights, and combining authorization with caching. So we had a revalidation issue. Luckily, like the no user experience was broken, but if you don't revalidate the authorization, it goes stale, and that can have consequences. But yeah, I have, and this is like, it really sucks because I'm very new at my current employer, and even though I'm not afraid to lean into taking responsibility for these kinds of implementations and deploys. Like, someone has to do it, and it also shows a lot when something goes bad. Like, what kind of culture are you operating in? Like, do people blame? Does it have like consequences? Like, what are expectations? All of this stuff. So, but it just sucks, right? And it was just a silly mistake. Like, I was making sure that like these revalidations weren't running duplicates, so it would only run one revalidation at a time. And then I was using a hash with a reference while this revalidation was pending. And then I used freaking like one reference to add the pending revalidation, and then I used a different reference to delete like that pending revalidation. So it never removed the pending revalidation. So it would only revalidate once. Like, it's horrible. But I learned a really important lesson. This is something that an AI would immediately pick up on. So what I'm going to do when I work on like critical things, because I tend to lean on reviews, but it's very, very hard to review these kinds of things. So I would not blame like the reviewers for not picking up on this at all. Like, first of all, it's my responsibility, but that's why we have reviews, right? So people share context and take a shared responsibility of what's going into production. But this is something that, yeah, an AI will pick up on. So I'm going to start using AIs for files that I have like critical changes to just ask it, like, did I make a stupid mistake here? It's very interesting. Yeah, but luckily I'm a grown up. I don't take too much. And again, like, it wasn't breaking anyone's experience. That's the most important thing. If anything, like, some users got to use the service a little bit more than they were supposed to. Anyways, so yesterday I was like ranting like crazy on this Bonsify project. And if you're jumping into this without any context, either go to the repo and read the docs there, or watch the stream from yesterday as I'm ranting about how we've gotten to this place in state management with React, where we've been applying all these principles that's very theoretical and not practical, that has just exposed a bunch of primitives and abstractions, and just removing us from this simple idea of application state just being like this tree of state that you can just change. An observation is like completely transparent. You don't think about that. The only way you think about optimization is making smaller components. Like, it's just a fact. Like reconciliation, observation, everything becomes slower if you just have a bunch of stuff in a component. So by narrowing down into nested components, that's how you optimize. But typically that hasn't been that's not how you thought about optimizations in React. You had to think about like these primitives and the reconciler and all of that stuff, and you shouldn't have to do that. It's too much overhead. Anyways, so one thing that we ended the stream yesterday. First of all, I hadn't really implemented properly the array handling of the proxy. Maybe we could actually talk about that, because the way you make a reactive system is actually quite straightforward. It doesn't require much code, but if you want to automate the reactivity, if you use an object, that's very easy to do. You just have a proxy, and then you use these, I think they call it traps, like a get trap and a set trap. So whenever you access a property or whenever you set a property, you can do whatever you want. And this is where all the observation happens. The problem though is if you are handling arrays, because arrays just fundamentally works differently. It's not like a get and set. You have methods on an array that mutates, like makes a change to the array. So you have to hook into these specific methods. Other methods are getters of the array, like map and for each and all of these. So you have to hook into them and make the exposed items reactive. And the point is that you shouldn't have to think about this. So that's where, like yesterday we had a bug, and that was just me not implementing the array proxy correctly. But I think it's working now. So the way it kind of works is that by default you have a single proxy. So you have a proxy which is the root object that holds all of your state, and then as components or whatever is accessing these fields, they actually access. So you have to start. This is the beauty of it, because you have to start at the root, right? You can't access anything without actually accessing the root. So you start out with one proxy, and then you might go into like one key of that proxy, and that triggers the get trap. So now you can go in and you can look at the thing you're trying to access. You can notify, first of all, that the current observer, which could be a component, is now tracking this object, the target. But you can also go in and you can go and grab the underlying value, and make that underlying value of the property also reactive. So now you have two proxies. You have the root and you have the object you accessed on the property. And the beautiful thing is, like, we're caching these proxies and everything, so you don't create them every time. And that's basically how it works. It's like very simple. You just have proxies. You have an object proxy and you have an array proxy. That's all you need. And then, as I said, the array proxy just has a more complex way of thinking about access and change, because it uses methods for that additionally to property access, using numbers instead of strings. Anyways, but the other thing that we had an issue with was the state machine concept, and I played around with it. I talked to ChatGPT a little bit, and I found a solution which I actually really like, because when it comes to expressing a state machine, it's really just so you have like some machine, like you have this union of state foo or state bar, for example. The problem with making the the object itself represent the state is that you have to replace the object. Like you depend on immutability basically to make that work. So it just affects the whole system. But what's interesting about these state machines is that you typically have some state that's always available, or some values that's always available regardless of the state you're in. So for example, with a to-do, regardless of being in a view state or an edit state, you would always have title and completed, right? That would always be there. And maybe you should be able to toggle completed regardless of that state. But what you can do then, instead of making the explicit states just a string, you make it an object where you say, you can call it mode, for example. So the mode is view, and then the state mode is edit. So now what you've done is that by accessing the to-do, you have these common values that's always there regardless of the actual state. But by introducing this state, you now have really a union of the states instead. So what it really looks like is this. And now you can go in and say, okay, when we're editing, we have new title, for example. And when we're in view, we can say edit. While in edit, we can say apply, for example, whatever, or cancel. So now we've achieved like having a common to-do item, and then you introduce states within the item or within the concept. And this lends itself very well to the code. So if you look at this, like I'm overcomplicating the to-do here, or maybe I'm not. Like it depends on how you think about things. Like for this tiny application, having these very explicit concepts of a view state and a edit state for a to-do, it doesn't matter, right? The app works fine without it. But when you reach more complexity and you kind of want to describe better in your state what this to-do item really is, and that it actually has two different modes of operating, it just describes it better. That's the point. And it's also more exploratory. So if someone is like in a component looking at the to-do, they can go in and look at the state, and they can actually read that, oh, this to-do can be in a view state, and it can be in a edit state. And if it's in a view state, you can toggle it completed, and you can edit it. And if it's in a edit state, you can cancel that edit, or you can apply the edit. And now the actual to-do type is title and completed, where it has a state. And what I also really like about this is like you can start with just a to-do and you can introduce everything there, and then you might discover that no, this doesn't make sense. These are like actually different states. And then you can move that stuff into a union of states instead. So it has this progressive feel to it, which I really like. And for the implementation, now it makes a lot more sense. All the typing and everything just works now. So when I create a to-do, I just pass in the title, and then I define these states, or these state creators, or whatever you want to call them, where I say, when I call view, we're going to return a view state. And the mode is now view, and we implement whatever is needed here. And then I have a reference to the actual to-do here. Because that's down here. This is where we define the to-do, and we set the initial state. So I have access to the to-do. I can change it, and I can also change its state. So when I do edit, we're going to set the state to edit. And then when we have the edit state, we have a function that returns that edit state. Mode is edit. We have a new title, which is title, which can be changed. And then if I cancel, I just go and change the state back to view. Or if I apply the edit, I'm going to update the actual title with the new title, and then we go to view. It's a really nice thing. And you can even have side effects in here, like this scope here. This function scope can close over, like if you have an interval running, for example, you can set that interval when you move into the edit state. And then when you apply the edit, you can just clear that interval before you move into the view state again. So it kind of cleans itself up when transitioning into new states, which is really, really great. And then it's very simple. We just do what we do with everything else. There's nothing special now about create to do or create some namespace. The only thing is that we have these like state functions creating these states. So yeah, it looks super clean to me. And but again, it's just a to-do item. But the concept is there. And there's a reason why state machines are has value. And it's because you're explicitly stating that, okay, this to-do is not just a to-do. It can actually be in a view state and it can be in an edit state. But what's additionally really great about this is that we're not putting toggle completed, edit, cancel, edit, apply, edit on the root of that item. Because then you don't know, like if you dot into the to-do in a component, you'll see that you can toggle completed, edit, cancel, edit, apply, edit. And that doesn't make any sense. Like, what if you're in the view state and then you call cancel edit? It doesn't do anything. It doesn't make any sense to cancel edit when you're in a view state. But now we actually tie the functionality to the actual state, which is a thing I've never been able to really accomplish. And that's because of the way React works. Like, state is one thing, having functions is something else. Well, now we kind of bring those two concepts together. Yeah. So I think this is really, really great. And I thought together we can go in and we can actually update this. Let's see. By the way, I've been playing Rocket League with our 4-year-old. He's like he's 4 years old, but he kicks ass in Rocket League. It's kind of insane. But we really like the music. Like, we listen to it in the car. And like the original, like Rocket League, what's it called? Original soundtrack, Volume 1. It's really, really awesome music. Okay, so state machines is a useful concept. At its core, it puts state and related functionality behind an explicit state. This has several blah, blah, blah. Normally, a state machine is implemented with a dispatcher type of concept. That means you can ask it to do anything at any point in time, but its internal implementation guards the execution by checking the current state. The bad side to this is that you'll never know from a consumption perspective what functionality belongs to what state. That's what I was talking about. By simply using a pattern, we can resolve this. Okay, so we can remove all of this. Create toggle machine. We don't actually need to describe this in any way. Toggler. Yeah, so the way we're gonna change this is we're gonna say, this is a weird machine, but yeah. So we're gonna say const, oops, state foo, let's do machine or toggler. Or toggle, let's call it toggler. Create toggler. And that's a reactive thing. Then we're going to return a toggler just right underneath. We can comment after we move. So here we're just going to say toggle state, toggler dot state equals bar, toggler dot state equals foo. Yeah, and I like, and the question is always like, it's behind state. Like, what do you call it? State dot state? That's weird. Do you call it state dot current? Do you call it state dot mode? I like to say mode because it emphasizes that there's a mode of operation. That's just me, but you could use current, name, whatever makes sense to you. So this represents the union of states. You can add any other base properties. So this is what I mean. Like if you think about X-state, for example, like X-state has state charts, which is like very, very difficult to describe with just code. Like you need to have, there's a lot of concepts in state charts that you can't express in code, but it also is like it's called a finite state machine. And this is a finite state machine. And it's better than the finite state machine, arguably better than the finite state machine of, maybe we can look at that. So X-state FSM. So here you kind of have that concept. And again, I feel like we're like overcomplicating the real value of things. So if we look at this, here you have create machine, it needs an ID, and then you set like the initial state to a string, and then you have states, and then, well, I guess, no, yeah, exactly. So I guess the challenge here is that you're gonna declaratively describe the machine, which lends itself to visual tools and portability and stuff like that. So that it's unfair to like compare this because this wants to be declarative. But the point is that maybe we can even take that example. But then you create a machine and then you transition by passing the state, and you have interpret and start and subscribe, and then you send, right? And you can just send whatever you want at any time. So there's a lot of like, there's a lot of abstractions here that kind of hides the core of a state machine, because the core of a state machine is this. And you can very easily express it in just code. And the thing is like, and then you can start talking about like they have entry actions and exit actions. So entry actions here, that's just the function. Where did we go? This is the entry action, like calling the function. That is the entry into that state. You can do whatever you want here. Like you can set up intervals, do whatever you want. And the exit actions, that's when it literally moves out of, like when you move into into a state, that state decides how to get out of that state. Because you can't call anything else than, like you don't have all these generic events that might or might not happen based on some declarative configuration. You literally say that this is the object now, and you can only access this object and these functions. So when you want to exit, this is really the exit action, right? So if I want to do something related to exiting, I just do that in the function or in the scope of this state. So yeah. So for me, it just simplifies a ton. And there's nothing special about this with like Bonsify or like this reactive primitive. This is just JavaScript. And the only reason we use reactive is so that we can like listen to these actual updates in the object. You could use any other. You could use reactive from Vue. You could use MobX. You can use whatever you want. Yeah, I think I made my case. Anyway, so you can add any other base properties that is available regardless of state, of current state. We create our machine by defining function transitioning to it. Yeah, we don't pass a callback. I want to mention the state functions close over the states, the object representing the state. You can do whatever you want there, like starting. Yeah, maybe we should change. We should do like a counter, create. Yeah, let's do counter, because I've been using create counter, and we're gonna, yeah, this is gonna be nice. So idle counting. So mode is, let's call it idle counting. And then we're gonna do counter. Yeah, and yeah, okay. So let's do, I don't think I need all these comments with this example. So we have a, and then we have count. So you should always be able to access the count, right? So what we're gonna do is mode idle, and then we're gonna say counting. And then in counting, we are gonna, or let's call it start. And then in counting, we are gonna set an interval. Set interval. And this is gonna update the counter.count. And then we're gonna return. This is gonna probably have some type. 1, 2. Oh, what did I do? There we go. 1, 2. 1, 2, 1, 2, 1, 2. There we go. Counting, and then we have stop, and then we say, oh, counter.state is idle, but we're gonna clear the interval first. Clear interval, right? And then we say, like, I love this. Like, this is exactly how it should look. Like, handling side effect. And then I'm not saying that this replaces all concepts in state machines. It's just that this is the most fundamental thing you can do. And then you can argue about like the benefits of the abstractions with XState FSM, and then state charts is like something way beyond this. But I think you could like explore state charts concepts, like how would you express like programmatically a state chart with this approach, because it's basically just nested and parallel states, and you can just keep like doing that, like creating like these functions that encapsulates an object within encapsulates an object that has states, where you can encapsulate each state like we do here, and so on and so on. Yeah, I really like this. I really like this. Oh, I'll... Cool. Let's commit that. State machines. Okay. Nice. Loving it. So I'm actually not sure. Like, the point is that theoretically there's likely some more bugs. Like implementing reactivity, even though it's a pretty straightforward thing, it's still like complicated. That's basically because of arrays. But we have the thing working, and I'm thinking about like how would I approach this. Like, what else should we do with this? I might record like an actual video of yeah, I think I'm gonna try to create a presentation out of this. Like, one thing is doing these streams, like not a lot of people watch them, but when I make like more precise videos, they have a tendency to spread a bit more. And again, this is not to like sell anyone on Bonsify, which is like I can't say without like giggling. It's more the ideas that comes up for discussion, or the concepts that come up for discussion. So you could kind of like start, yeah, basically based on the docs, do like created a presentation format. And then you could like write some code, basically the to-do app, because we're touching on like many different concepts there. Yeah, deriving and accessing parent states. Like, we could show the example where we actually each item can remove itself, because then we need to pass in the parent. Yeah, persistence. Yeah, we don't really have any disposing. Yeah. I'm gonna think about that, and then we'll see. But I think I'm gonna keep the stream short today, and then have some other stuff to do. So yeah, thanks for following along, and bye for now.